Now, what is this V perpendicular? Well, we have F centripetal is equal to GMM over D squared is equal to mv squared over d, right? So from physics 1 we have this is a force of gravity. This is equal to centripetal acceleration, right? mv squared over r or mv squared over d. So we have d and d gonna cancel. We have mv squared is equal to gmm over d. And then if I do half and half, therefore the kinetic energy of centripetal motion is equal to 1/2 gmm over 2d. So if already something is circulating around another object, it has kinetic energy equal to that. Now this portion, the gmm over d, is the absolute value of the potential energy that it has, right? Gmm over r. So let's say for now that you are near the surface of the earth so that the d is the same as the r, okay? So we'll just say gmm over r. So we'll put that over here. Over 2r minus gmm over r. So what's going to end up happening? Well, when you combine this, you're going to get gmm minus gmm over r. You go 2 and 2. So you get 1 minus 2 is a negative 1 on the top, and you get 2r, right? So you end up getting half mv initial squared minus gmm over 2r is equal to 0. And then this 2 and this 2 cancel. So the initial velocity of escape is actually going to equal what? V initial, m and m cancel, square root of gm over r. So what's missing? The radical 2. Okay? So this time if you're a natural satellite, to escape is going to be less than if you're just on the surface of the earth, just going around the earth, or if you're just not even going. So if you're on the equator, the rotation of the earth is helping out a little bit. If you're on the North or South Pole, you don't have that rotation. But if you're a natural satellite, it's going to be easier. So what's going to be the value now? The escape velocity. So it's going to be 1 over root 2 of 11.18. So it's going to be 7.905 kilometers per second. So for a natural satellite to escape from near the surface of the earth, it's going to be 7.905 kilometers per second. If they're farther out than the surface of the earth and farther, the greater the height, it's going to be even easier. Okay? So you're going to have, it's about, roughly about 3 kilometers per second less than the escape velocity needed if you're just on the surface of the earth. Okay, so you can see here how useful these calculations are to rocket science and to sending out spacecrafts to outer space and for exploration of the universe. Thank you.